What we're going to do in this short practical is measure the IV characteristics of a filament bulb, which is this small bulb here. So obviously I is current and V is voltage. So we want to see how the current through varies with the voltage across this component. Okay. Now what we've got here is a simple circuit with the bulb in. Now we've got a power supply and we've got a current flowing through the bulb. Right, conventional current, as we know, goes from positive, which is the top, round to negative, that's the longer bar. But in reality, it's electrons flowing from negative round to positive through the bulb. Okay. Right, and then the problem with this power supply is it only gives a fixed voltage. I think this is set to about 6 volts. Now, if we want to measure the IV characteristics, we want to see how I and V vary with each other. So that's no good. So what we're going to use instead is a bench power supply like this, okay, which is much better because it can give a range of voltages. So what we're going to do, red terminal to the top, black terminal to the bottom, and then we can vary the voltage. And obviously the bigger the voltage, the bigger the brighter the bulb. Right, now let's go back to 0. Well, we want to measure the voltage across and the current through. So let's do voltage first with the voltmeter. Now in both cases we're going to be using these multimeters. Okay, so obviously a multimeter can measure DC voltage, AC voltage, DCA, that's DC current. It can also measure the resistance as well. Okay, so we want this to be the voltmeter, so we're going to set it on 20 volts DC. Right, now the two terminals here, everything always utilises the COM, whether you're measuring resistance, current or voltage. And as you can see here, there's a V, so we want that terminal there, like that. Okay, so ready to measure voltage. Now we want the voltage across the bulb. Now the top one was positive and the bottom one was black or COM. So that's going to have to go above the bulb. So this is the top terminal. This is the positive terminal for the voltmeter, and that one goes underneath like that. Okay, so if we turn that on, so that should show us that the positive voltage from the power supply is given a positive voltage here. Right, you might notice already there's a discrepancy between what's shown here and what's shown here. Well, the one we're going to trust is always the voltmeter. We're always going to trust the meter that's designed to measure accurately the quantity you want to measure. Okay, obviously this has not been calibrated brilliantly. Right, so we've got a voltmeter measuring the voltage across the bulb. As we can see, we can have a range of voltages across our filament bulb. Okay. Lastly, we want the current through the bulb. Again, we're going to use a multimeter. Right. Now this one here, identical, but we want to measure DC current, so DCA. Right. We're going to run the biggest current first. Okay, up to 10 amps. We can measure smaller currents between this terminal and the middle one. Okay, but as you can see there, that says max 200 milliamps. So if we go above that, when we're measuring current here, we're going to blow the internal fuse in this. So we always have to try the bigger current first, or assume we're measuring a bigger current first. So 10 amps, and again we're using the COM, but we're using the top one here. So can you see there? 10 amps DC. Right, we want this to be in series in the circuit. So obviously the voltmeter is in parallel across the bulb, but the ammeter needs to be in series. So I'm going to break the circuit there, and the positive terminal is going to go before, and the black terminal is going to be after. Okay, so there we have it. We now have the voltmeter to measure current, the voltage, and the current to measure the ammeter to measure the current through the bulb. Right, so let's just check whether we've got the right current setting for our multimeter. Okay, now don't want to go too bright, we don't want to blow the bulb. So we want to go maybe up to about 8 volts. So, as we can see here, okay, we've got, how much is that? 0.38 amps, which in milliamps, if you convert that to milliamps, that's 380 milliamps. So clearly that's higher than 200 milliamps, so we want to stay on that setting. If we were to use the smaller current scale, when we went up past 0.2, it would blow the internal fuse. So we're going to stick with it like this. Right, just one last check. We've got a positive voltage producing a positive current. So now we want a range. Right, this is very useful, especially when it comes to plot a graph, is can we make the origin a valid data point? Well, in this case we can, because we have 0 volts producing 0 current. Might sound blindingly obvious, okay, but having the origin as a valid data point is very useful. Right, let's go for our first data point. Well, there we have it, we're going to go with this one. So 0.95 volts gives a current of 0.12 amps. 1.89 volts gives a current of 0.17 amps. 2.82 volts gives a current of 0.21 amps. 3.71 volts gives a current of 0.25 amps. 4.71 volts, 0.29 amps. 5.58 volts, 0.32 amps. 6.45 volts, 0.35 amps. Last one. 7.43 volts gives a current of 0.38 amps. Right, that's for the positive voltages. We want to see now what the effect on a negative voltage will do to the current. Now, the quick, easiest, most convenient way of doing this is to swap the terminals over at the power supply. As simple as that. In fact, I'm going to do it there, because that makes it more obvious for you guys what I've done. Right, so now we've got conventional current going the other way. Right, let's get some values. Again, the origin, we've got 0, 0, so the origin is a valid data point. Right, we've got minus 0.94 volts, gives minus 0.12 amps. Okay, so minus voltage, minus current. Might sound obvious, but this is really, really important when we come to plot the IV graph. Next one, minus 1.87 volts, minus 0.18 amps. Minus 2.79 volts, minus 0.22 amps. Minus 3.68 volts, minus 0.26 amps. Minus 4.68 volts, minus 0.29 amps. Minus 5.55 volts, minus 0.32 amps. Minus 6.42 volts, minus 0.35 amps. And the last negative one, minus 7.40 volts, gives a current of minus 0.38 amps. There you have it. There's the values of I and V for a filament bulb, with the values of positive voltage and current and the values of negative. Right, we need a graph now. So IV characteristics and IV graphs means I is on the Y. So we've got I on the Y, V on the X. Don't forget the negative values.